Today we are going to discuss what is known as decision making with experimentation. Please look at this diagram here. This particular diagram we had drawn in our previous class. Very quickly, if we look at, then there were three decision options before us: construct a large plant, construct a small plant, or do nothing. And market could have been favorable or unfavorable, and there are some prior probabilities, and the payoffs were computed, and based on which we got 40,000 and we constructed a small plant. But the question came that the large plant had a 200,000 option. So, is there any alternative way we can look at? So, one such solution was that doing a market survey. If we do a market survey, the result could be favorable or unfavorable. What should be our decision if the market is favorable or the market is unfavorable? Look at the slide. So, for this particular problem, we can say that for this decision problem, the plant construction with market survey, the market survey is an experimentation. The company has two decisions to make, whether to go for market survey, and if market survey is favorable, what type of plant to construct, else what type, right. Here the second decision is dependent upon the outcome of the first, right. So, it is a kind of situation where there are number of decisions, and the first one is the answer of the first one would really look, the create the kind of second decision option. So, if we take up this problem, so there are some additional consideration. Already we have seen the problem number of times. Before deciding about building a new plant, the company has an option to conduct its own marketing survey at a cost of $10,000. So, it is not that market survey is free, the market survey also has a cost. The question is that these 10,000 additional amount we are paying, obviously with a hope that better results would be obtained. Now, information from survey could help in deciding which alternative to pursue, that is either large or small or no plant. That means, whenever we have a decision making with experimentation, the experimentation itself cuts a little bit of payoff. We give up that payoff thinking that a better decision could be made, and the outcome of the survey would decide the kind of alternative to pursue in the future. So, that is the kind of situation, but there is something more to it. What is that? The market survey is to be conducted at a cost of 10,000, that is the point number 1. The point number 2 is that market survey will not be able to predict the state of nature with 100% accuracy. If it would have done with 100% accuracy, things would have been very simple. We simply could have done with, if these are our payoffs, if market survey is favorable, do this, market survey is not favorable, do this. But here, since it is not 100% accurate, we have to do what is known as a Bayesian analysis. The market survey can only give additional information on the probable states of nature in the form of following conditional probabilities, right. It could be survey favorable given the market is favorable, survey unfavorable given the market is favorable. The third option, survey favorable given the market is unfavorable, survey unfavorable given the market is unfavorable. So, all these 4 conditional probabilities, they have some value, but please remember that they should occur in pairs. The first two are survey favorable given favorable market, survey unfavorable given favorable market, they should add up to 1. The same thing about the conditional probabilities with respect to the unfavorable market, right, because when the market is favorable, survey could be either favorable or unfavorable, and those are going to be their probabilities. Before we embark on this problem, let us look at this at a slightly bigger respect, because whenever we talk about experimentation, there are different experimental situations that can occur. One example which you will get in what is known as the Hillier and Lieberman's book, that is about a particular situation where decision is to be made whether to dig for oil or do not dig for oil, simply sell the piece of land. So, these are the decisions that one has to make. The decisions, this is an example, this example basically looks at the two choices, two decision alternatives one is dig for oil and the two is sell the land. Because a piece of land is obtained, the two choice is there, either dig for oil or sell the land. Because if you dig for oil and there is no oil, obviously there would be lot of expenses and there will be loss. Now, the question is that they have certain payoffs. If we dig for oil, then again two things can happen, that either it is oil is available or it is dry. Suppose oil is available, then you get high payoff, and if it is dry, then loss. But if you sell the land, then some payoff you will get under both situations, right? Both situations, some payoff, not much, but some payoff will be obtained. The question therefore comes that should we dig for oil and should we sell the land? Obviously, if you dig for oil, it is like a kind of fortune hunting, because it could be high payoff or it could be dry, and obviously the probability for the oil would be on the lower side, something like, suppose this probability could be something low as 0.25, whereas the dry probability could be as high as 75%. Now, question is that on the face of it, if you make a decision problem calculation, then you might get best decision could be sell the land. But obviously, the person who has bought the land definitely has gone for digging for oil in search of high payoff. So, what it can do? It can, the company can actually go for experimentation. Now, what is that experimentation? Experimentation could be a geological survey. Right, a geological survey, and that geological survey use some instrument, and through that instrument it can come out with a set of conditional probabilities, that if the kind of test that it conducts, if the test becomes positive, then what is the probability that it is oil exists, or what is the probability that it is dry. So, when those conditional probabilities are given, then obviously based on that, those conditional probabilities, the dig for oil and the sell the land will have now the initial decision that whether to conduct geological survey or not. If we conduct, then should we dig for oil or should we sell the land, and if the geological survey tells that it is dry, then whether to dig for oil or sell the land, right. So, this is a kind of example that we can think of. The second example could be that in a particular situation, particularly let us say testing or acceptance testing. Now, we can think of an acceptance testing, a situation, acceptance testing. So, sometimes what happens that when you are in a particular market and you are buying, let us say, fruits, then what happens that you have an to alternatively that whether to accept, supposing a lot has come and whether to accept the lot or not to accept the lot, right. So, when you have to accept the lot, then there are certain quality requirements. So, there are quality requirements Now, if the fruit lot is good, then you get certain payoff, but if the fruit lot is bad, then your payoff is low. So, the question is that whether to accept the lot or reject the lot. Right, and obviously based on the various situations. So, here again usually it is resorted to certain experimentation, and that experimentation is that, as the example shows, about acceptance testing, that test only, let us say, one fruit. Now, question is, when we test only one fruit, is it good or it is bad? Suppose the fruit is good, then how does it modify our accept and reject decision, and if the fruit is bad, what should be our decision? Because unless we create a kind of acceptance testing norms, because it is, see, particularly fruit, we just cannot test 100%. If you test 100%, then nothing remains. So, we have to sample only limited number, let us say 1 or 2 or 10, let us say maximum. Now, question is, this particular experimentation, when test only one fruit, how does this particular experimentation revises a particular decision? So, like that we can think of several such examples. You can think of an example from credit rating, we can think of examples from share market, or as I have given example previously, the suppose someone is having a disease and goes to a doctor. The doctor actually asks the patient for a test. The test, if the test is positive, then one kind of decision situation, the whether the person is having the given disease or not, and if the test is negative, then the probabilities get modified in a different way. So, all these different decision situations, they all have a similarity. Basically, whenever we do experimentation, there are few things to see. Any experimentation, a few things to see. The first one to see is the decision structure. Means, as I have discussed already, that what is our first decision? What is our first decision? That is, do the experiment or not. That is the first decision. Then second set is, if experiment result is positive, then what? Else what? So, that is the decision structure. Do the experiment or not? If experiment result is positive, then what? Else what? Then number 2, what we need to think of is, what are the states of nature? Now, when we look at the states of nature, we have to understand what were a priori probabilities. And next thing to see is, in view of the experiments or experiment, what posterior probabilities are obtained. Right. So, first of all, there are a priori probabilities, and then in view of the experiment what posterior probabilities are obtained, because the a priori probabilities will now be replaced by the posterior probabilities. And again there are two different sets of posterior probabilities. One is for if the experiment result is positive, the other is if the experiment result is negative. So, these has to be done, and the third one is revised decision tree. Right. The decision tree also has to be revised, right, recompute payoffs. So, all the payoffs had to be recomputed on the basis of the number 1, that is the decision structure, and number 2 is the states of the nature. So, all of these when we are putting together, we can actually do the experimentation in a proper manner. So, this is the broad structure under which we shall be able to do the experimentation. Now, let us come back to the problem once again. What we are in between, that there was a market survey, the market survey was having a cost, market survey is not 100% accurate, and therefore, there are conditional probabilities, and those we have already discussed. Now, you see, we have to do first of all a Bayesian analysis. So, what are those? First of all, you see that there was a probability of favorable market, the a priori probabilities, that was without any market survey information, the best estimates of a favorable and unfavorable market they were. The PFM favorable market was 0.5 and PUM unfavorable market was 0.5 also. And then there are these 4 options for favorable market, the survey could be favorable or survey could be unfavorable. Here survey could be favorable, survey could be unfavorable. So, these conditional probabilities are written here. So, this is the Bayesian analysis diagram, and these are the initial probabilities. Let us see how these computations are done. These computations we have already done for a previous problem, but let us have a repeat on this. The first one is we have to compute what is known as the joint probabilities. What is joint probability? A joint probability is that the P of favorable market intersection survey favorable is basically a multiplication of the probability of, that is the a priori probability for the favorable market multiplied by the conditional probability, right. So, this let us write down and understand this once again, that what is how these computations are done, that probability of P FMSF PFMSF equal to probability of favorable market intersection the survey favorable, right. So, again there are 2 probabilities, one is the a priori probability, which is the probability of FM the favorable market, and multiplied by probability of survey favorable given favorable market, right. So, what are these? This is, these are first of all we have to understand this is a joint probability. The joint probability is a multiplication of the a priori probability and the conditional probability. Right. So, basically that is how the calculations are done. The joint probability of favorable market and survey favorable is the a priori probability of favorable market multiplied by the corresponding conditional probability of survey favorable given favorable market. So, when you do this multiplication, we get what is known as the joint probability of favorable market and survey favorable. So, let us go back there once again. So, this is where the probability of favorable market and survey favorable, the interaction and intersection, the intersection would be 0.5 into 0.7 equal to 0.35. So, similarly, we have got all of these calculations, and after these calculations, look here, then we can actually calculate what is known as the unconditional probabilities. The unconditional probabilities are basically, look here, one side we have these a priori probabilities for favorable market and unfavorable market. On the now basically there are two types of situations, survey favorable and survey unfavorable. Now, what we can do, if we take out the survey favorable cases, right. So, there are two survey favorable cases, one is FMSF and UMSF. If you add these two, if you add these two, that is PFMSF plus PUMSF, that is 0.35 plus 0.1, that is the called what is known as the unconditional probabilities. Is it all right? So, let us look at this once again, just for, because I am repeating this because this is a slightly difficult topic and one should be very clear what exactly we are talking about. So, this is favorable market, this is unfavorable market, this is survey favorable given favorable market, this is survey unfavorable given favorable market, this is survey favorable given unfavorable market, and this is survey unfavorable given unfavorable market. So, these are some probabilities. Right. So, these are a priori probabilities and these are conditional probabilities. When you multiply, you get what is known as the joint probabilities. Right. So, these are the joint probabilities. So, a priori probabilities multiplied by conditional probabilities equal to the joint probabilities. So, once again this was 0.5 this was 0.5, these values are 0.7, 0.3, 0.2 and 0.8. So, when you multiply, we got equal to 0.35, we got equal to 0.15, we got equal to 0.10 and we got equal to 0.40. Now, if these two are added, right, because in both cases we have what is known as the SF condition, right, survey favorable condition, then we get what is known as PSF, which is equal to 0.35 plus 0.10 equal to 0.45, right. Whereas, if I add these two, then we get probability of survey unfavorable, which is 0.15 plus 0.40 equal to 0.55. Okay. So, this is how, and these probabilities are called unconditional probabilities. Sometimes they are also called total probabilities, right. So, anyhow, this by multiplying a priori probabilities and conditional probabilities, we have got the joint probabilities, and adding corresponding joint probabilities, we get what is known as the unconditional probabilities. So, look at the slide, we have put those figures that there are unconditional probabilities 0.45 and 0.55. Now, if we then understand that, look here, that survey favorable is 0.45, it has got two components. One is for favorable market, which is 0.35, and unfavorable market 0.10. So, obviously, if we want the posterior probabilities, that when there is survey favorable, then how much is for favorable market, how much is for unfavorable market, that has been divided into this ratio, 0.35 is to 0.10. So, what happens? We have survey favorable, and for survey favorable, see, we can actually draw what is known as a secondary diagram, right. What is a secondary diagram? That is, we can actually now look at this way. Suppose survey is favorable, and this is survey unfavorable, right. So, what we got? We have got P of survey favorable unconditional probability, which comes to 0.45, and how much we have got survey unfavorable is we have got 0.55. Now, out of that, what are the two components? The two components is, again, it could be two things. One is favorable market and unfavorable market, right, and this side also favorable market and unfavorable market. Okay. And those are, since this one, probability of favorable market given survey favorable and probability of unfavorable market given survey favorable. So, this one, since the ratio has divided into 0.35 is to 0.45, so this one would be 0.35 by 0.45 equal to 0.78, and this one will be 0.10 by 0.45 equal to 0.22, right. So, look at the slide once again, that what we have, that probability of the favorable market to survey favorable is 0.78 and the other one is 0.22. Similarly, on the other side, the probability of favorable market given survey this thing and probability of unfavorable market given survey unfavorable, that has divided by 0.15 and 0.40. So, this one is 0.15 by 0.55 and this one is 0.40 by 0.55 equal to 0.27 and equal to 0.73. So, these are called what is known as posterior probabilities. Right. So, this is how the posterior probabilities are calculated, and we stop here. We continue the similar discussion in the next class.